October 2025. An object from beyond our solar system passes Mars. 5 spacecraft watch from orbit. 5 nations hold the most powerful cameras ever sent to another world. And then nothing. No images, no data releases, just silence. This is the story of what didn't happen. Or rather what happened but was never shown to us. It begins with China's Tian-1 mission, a spacecraft that had never been shy about sharing its discoveries. For 4 years, Tian-1 had been a reliable messenger from Mars. Thousands upon thousands of photographs, detailed maps of craters, valleys, and dust storms. China broadcast them proudly. Each image a statement to the world. We have arrived and we are here to stay. But when the interstellar visitor known as 3I-Atlas swept past the red planet in early October, Tian-11 went dark. No photos, no press releases. Beijing offered no explanation, no acknowledgement that anything unusual had occurred at all. And China wasn't alone in its silence. NASA's Mars Reconnaissance Orbiter saw the flyby. So did Europe's Mars Express and ExoMars orbiters. The United Arab Emirates Hope probe was there, too. Together, they formed the most capable observation network humanity had ever positioned around another planet. Under any normal circumstance, the data would have been everywhere within hours. Scientists love to talk. Space agencies love to compete. The race for discovery is written into their DNA. When something extraordinary happens in space, institutions trip over themselves to be first with the news. But this time, everyone stayed quiet. At first, the explanation seemed reasonable enough. NASA blamed the United States government shutdown, which had furled key personnel just 2 days before the encounter. The European Space Agency said their images were still being processed, still under review. Standard procedures, they insisted, nothing unusual. The UAE deferred to its international partners. But as one day became 3, then 5, then a full week without a single released image, something felt wrong. This wasn't bureaucracy. This was coordination. A silence too uniform to be coincidence. Amateur radio operators noticed something strange. Encrypted transmissions were still flowing from Mars. The orbiters were active. They were sending data back to Earth. Lots of it. The bandwidth signatures showed massive file transfers, high-resolution imagery, spectroscopic readings, all the data you'd expect from a historic observation. But none of that information was reaching the public. Perhaps the silence made sense when you understood what 3I-Atlas actually was, or rather what it appeared to be. Because from the moment astronomers first detected it months earlier, nothing about this object fit the rules. Normal comets are mostly water ice. Simple chemistry. They vent steam as they approach the sun, creating those spectacular tails we photograph from Earth. Predictable, well understood. But 3I-Atlas expelled carbon dioxide at a ratio of 8 parts CO2 to 1 part water. No known natural body had ever shown that chemistry. Not in our solar system. Not among the handful of interstellar visitors we'd observed before. Its surface reflected light in ways that suggested nickel, but showed no iron. That's backwards. Planetary formation doesn't work that way. When stellar systems form, iron and nickel appear together. Always. It's fundamental cosmochemistry. And strangest of all, it vented gas constantly. Powerful jets that should have pushed it off course. Newton's third law. Every action has an equal and opposite reaction. Gas shooting out one side should spin the object, alter its trajectory, create wobbles in its path. But its trajectory never changed. Not by a millimeter. As if Newton's laws simply didn't apply. Then there was the path it took. Venus, Mars, Jupiter. A sequence of near-perfect planetary encounters that computer models said had less than 1 chance in 20,000 of happening randomly. It was threading needles across the solar system with impossible precision, like a billiard ball that somehow knows exactly where every other ball will be. Astronomers tried to explain it with gravitational assists, with subtle perturbations from the outer solar system. The math never quite worked. The trajectory was too clean, too efficient. Some measurements suggested 3I-Atlas might be 7 to 14 billion years old, older than our Sun, perhaps older than most stars in the Milky Way galaxy itself. How could something survive that long in space without being destroyed, without colliding with anything, without being torn apart by gravity or radiation? Natural objects accumulate damage. They get pitted, fractured, eroded by cosmic rays over billions of years. Unless it was designed to endure. A private research group ran the numbers using Bayesian probability modeling. They calculated the odds. Natural object versus artificial construction. The result stopped them. The statistical factor favored artificial origin by 10 to the 28th power. That's a 1 followed by 28 zeros. A number so large it defies comprehension. For context, there are only about 10 to the 80th atoms in the observable universe. The researchers published their math in a technical journal, but carefully avoided stating the obvious conclusion. They buried it in dense statistical language, hedged every statement with caveats. But the numbers, however, spoke for themselves. Which brings us back to October and that carefully orchestrated blackout. Under normal circumstances, a discovery this significant would trigger fierce competition. Every space agency racing to publish first, to claim credit, to plant their flag on a historic observation. Academic careers are built on moments like these. Instead, every statement sounded identical. Data under review. Preliminary calibration in progress. No comment at this time. As if the world's scientists had suddenly lost all curiosity. There's a protocol for this. It was written decades ago by researchers involved in the search for extraterrestrial intelligence, a set of guidelines for what to do if evidence of non-human technology ever appeared. Most people assumed it would never be used. Rule 1. Verify independently before saying anything publicly. Share data privately with other agencies. Make no unilateral announcements until multiple groups have confirmed the same thing. Rule 2. Coordinate with international partners, presents a unified message, prevents panic or misinformation. Rule 3. Involve government authorities before public disclosure. National security implications must be assessed. In theory, these rules prevent embarrassing false alarms. In practice, they create exactly what we saw, coordinated silence. The protocol assumes discovery will happen through radio telescopes, through deliberate signals. It wasn't designed for something passing through our solar system, visible to multiple agencies simultaneously. But apparently it worked anyway. By mid-October, attention shifted to a crucial date, October 29, 2025. Perihelion, the point where 3I-Atlas would pass closest to the Sun, about 203 million kilometers away. For an ordinary comet, this proximity would be catastrophic. Solar heat would boil away ice, create enormous gas jets, possibly tear the nucleus apart completely. Scientists prepared their instruments for a spectacular show of physics and chemistry. Destruction on a cosmic scale. Europe's ExoMars orbiter released a few preview images as the object brightened. They showed faint streaks around 3I-Atlas, barely visible against the background. Officials insisted these were just background stars or sensor noise, technical artifacts. No confirmed secondary bodies, the captions read. But image analysts saw patterns they couldn't explain. Symmetrical arcs around the main body, too structured to be random interference, too consistent across multiple wavelengths to be equipment malfunction, too regular to ignore. When perihelion arrived, every telescope on Earth and in orbit turned toward the inner solar system. Ground observatories from Chile to Hawaii, space telescopes in Earth orbit, even amateur astronomers with backyard equipment tracked the approaching dot of light. 3I-Atlas flared brighter as expected. Its jets formed luminous streams visible in infrared. Solar radiation excited the gas, making it glow. But instead of breaking apart chaotically, spinning wildly as pressure built asymmetrically, it stabilized. The emissions pulsed rhythmically, steadily, like a heartbeat. And then something extraordinary happened. 6 smaller points of light detached from the main body. They drifted outward slowly, maintaining perfect spacing, moving in formation. No debris cloud, no rotation, no random scattering like you'd expect from explosive fragmentation. At NASA's Jet Propulsion Laboratory, where operations had partially resumed after the shutdown, Analysts watched their screens in stunned silence. Fragments, someone whispered. Trying to make it normal, trying to fit it into known categories. They're moving too cleanly, another replied. The same scene played out in mission control centers across the globe. Darmstadt, Germany, Beijing, Dubai. Moscow had a telescope network watching too, though they said nothing publicly. 6 objects separating, each maintaining precise distance from the others, trailing in sequence behind the parent body like a formation of aircraft. This wasn't fragmentation. Comets break apart violently. Pieces tumble. They follow slightly different orbits, spreading out chaotically over time. This was something else entirely. In the weeks that followed, Europe's Jupiter icy moons explorer JUICE maintained surveillance from millions of kilometers away. The spacecraft was en route to Jupiter, but its instruments were powerful enough to track objects across vast distances. And what it saw defied easy explanation. A convoy. Multiple small objects accompanying 3I-Atlas as it moved outward from the Sun. They spread gradually across thousands of kilometers of space, but their formation remained remarkably orderly, like ships sailing in formation, maintaining station relative to each other. Each object reflected sunlight sharply, as though metallic, hard surfaces, not the dusty, irregular shapes of comet fragments. Infrared scans showed no outgassing, no vapor trails, no dust,